In this video, I'm going to talk about the backup bandwidth and also promotion. You know that in the previous videos, we learned about MPLS traffic engineering fast rerouting feature for node protection and also for example, link protection. Also, we talked about the configuration of multiple backup tunnel. You know that we can configure multiple backup tunnel for protecting a node or for protecting a link in traffic engineering. Here we have now one question. What is the question? Let me talk about that. Look at here. In this scenario, we have two tunnels from the router 4 to the router 5. The first tunnel is tunnel 0, protected tunnel 0, and then the next tunnel is tunnel 1. And also, we are configuring two backup tunnel 100 from the path of R1, R2, R3, and the backup tunnel of 101 from the path of R1, R7, R3. The question is that how we can determine that which protected tunnel use which backup tunnel. Maybe you say, what is the importance of this, for example, selection? What is the importance of the selection of, for example, tunnel 100 with tunnel 0 or tunnel 100 with tunnel 1? Let me to explain this feature. Look at here, this is the configuration of this scenario. We will use it, but for the understanding of the backup bandwidth, let me to use this scenario. Look at here. You know that here I configured before two tunnel from the router 4 to the router 4. Now router 4 connected to router 1, for example, and after that here we have another link between the router 1 and router 6. This is the router 6. After that the router 3, and after that the router 5. Here we have two tunnel 0 and also tunnel 1. Both of them is from router 4 to the router 5. Okay, this is the first tunnel, and the second tunnel is tunnel 1. And as I, for example, can show you here, look at here, the requirement of the tunnel 0 is the bandwidth of 1000 kilobit per second. Because of that, this tunnel has this requirement, bandwidth 1000 kilobit per second, and the tunnel 1's requirement about the bandwidth is 500 kilobit per second. Okay, we don't have any problem now because we have this amount of bandwidth from the path of R1, R6, and R3. Okay, after that we need to configure the backup tunnels, okay, for protecting, for example, their R6 as the protected node, or if you want, you can protect one link. Okay, both of them are same. Here we don't talk about the protected node or protected link. Both of them can be used. Okay, but here, as you can see, we have a link between the router 1 and router 2. This is the router 2, and then after that we have another link from router 2 to the router 3. We need to configure one backup tunnel from this path. You learn how we can configure these backup tunnels. This is the next hop backup tunnel from the R1 to R3. Okay, this is the first tunnel. Let me to use the name of this tunnel as tunnel 100. Okay, and the tunnel 100 is establishing from R1 to the router 3. Also, here we have another path. For example, the R1, R7, R3. This is the link from the router 1 to the, for example, router 7. This is the router 7. After that, the router 3. And this is the next link, and this is the R3. Very good. And now we are configuring another backup tunnel from the router 1 to router 3 from this path. Tunnel, for example, 101 from the router 1 to the router 3. That's it. Okay. Now we have two backup tunnel. This is the backup tunnel. Let me to write B here, means this is the backup tunnel, and also this is another backup tunnel. Also we have two protected tunnel, the tunnel 0 and tunnel 1. You know that by default the traffic engineering tries to load balance this, for example, tunnels with the backup tunnels. This means that, for example, for tunnel 0, maybe it uses the tunnel 100, okay, and for tunnel 1 it uses the tunnel, for example, the 101. Okay, you know it, and you saw this feature in the previous videos when we configured multiple backup tunnel. In the normal cases we don't have any problem, but assume that that these two tunnel 100 or tunnel 101 has different capacity, okay, has different capacity, and these capacities may be important for us. For example, you know that we are using for tunnel, we need for tunnel 0 1000 kilobit per second, and for tunnel 1 500 kilobit per second. Assume that in the for example in the path of tunnel 100 we have 600 kilobit per second of bandwidth, okay, and also in the tunnel 101 we have for example 1000 kilobit per second of bandwidth. This means that both tunnel, the tunnel 100 and tunnel 101 can for example can be used for tunnel 0 and tunnel 1 if we choose the tunnels correctly, okay. If we use for tunnel 0, okay, the tunnel 100, okay, we will have problem. Why? Because tunnel 0's requirement is 1000 kilobit per second of bandwidth, but in tunnel 10, in path of tunnel 100, we have only 600 kilobit per second of bandwidth. This is our problem. But if you use for tunnel 0 the backup tunnel as tunnel 101, we have 1000 kilobit per second. We need 1000 kilobit per second of bandwidth, and also here we have 1000 kilobit per second of for example bandwidth. And for tunnel 1 we can use the tunnel 100. Because of that, tunnel 1 can send its traffic when the main link is failed from the tunnel 100. We will not have any problem, okay. Because of this, it is important to selecting the for example backup tunnel correctly according to the bandwidth for the main tunnel or protected tunnels. We call the tunnel 0 or tunnel 1 as the primary tunnels. Let me to use primary tunnel, primary or protected, both of them are same. And also the tunnel 100, okay, tunnel 100 and tunnel 101 are the backup tunnels or secondary tunnels, okay, backup tunnels, okay. Now here we need a feature, that feature can use the suitable backup tunnel for a primary tunnel. You know that if we are using in this scenario the for tunnel 0 the tunnel 100 as the backup tunnel, we will have problem. And because tunnel 1, you know that the tunnel 1 now uses the tunnel 101, because of that only we will have only 500 kilobit per second of bandwidth, remaining bandwidth, and because of that the tunnel 0 doesn't have, cannot use the tunnel 101. We need to exactly use this with this kind. For example, tunnel 0 should use the tunnel 101 because here we have the amount of required bandwidth, and also in the tunnel 1 from tunnel 100 again we don't have any problem. The traffic engineering, okay, can load balance the tunnels, the primary tunnels and the backup tunnels without regarding to the for example bandwidth that we have on the on these backup tunnels, okay. Maybe you say that the for example traffic engineering should consider this requirement. Yes, it's okay, but we need to configure the backup bandwidth. Backup bandwidth means the bandwidth of the backup tunnel on the tunnels. We call it backup bandwidth. Look at here. When you say backup bandwidth, means the bandwidth that the backup tunnels, okay, can forward. When you are configuring the backup bandwidth, TE can understand that every or each backup tunnel can forward how many bits, okay. Don't mistake this feature with the, for example, configuring the MPLS traffic engineering tunnel after that bandwidth requirement of a value, okay? This is not that feature. This is the backup bandwidth. When we say backup bandwidth, means the bandwidth that a backup tunnel, okay, can be used for that amount of bandwidth. Okay, we need to configure this amount of bandwidth. If you don't configure this amount of bandwidth that every tunnel can forward traffic, the traffic engineering maybe uses for tunnel 0, okay, or for tunnel 1, the tunnel 100, okay, and maybe or tunnel 101, then this is not a good choice. You need to configure the backup bandwidth on the tunnels to T can understand how many bits can be sent from that backup tunnel, and because of that it can